Hey guys, it's Duncan from 21417A Robotics, and we are going to do an explanation on our second robot, the one we just took to Speedway. We're going to be rebuilding pretty soon, and so before we take this apart, we figured we'd explain it. So we're going to start from the bottom up, so we're going to start with the first system, which is the drive. So this one is a 600 RPM 6-motor drive. So it's pretty fast. We got the double traction wheels to keep people from pushing us around. And this was, we like this drive so far. It's pretty much what we've been running for the past few years. And it has a lot of speed and also maintains enough pushing power and torque to be able to not get absolutely pushed around the field. And one thing we did new on this drive that we haven't really done on drives before is we used high strength shafts. That was just to get some really high strength structure into a really small space. And this is a very, very, very rigid drive. So it's not gonna break or anything or bend. And it also is very compact. So we really like this setup. We got our pneumatic tanks up here, really compact, stuck in the C channel, so there's no way it can fall out. And then you'll see our battery is down here. And the wire actually keeps the battery in. So even if the battery slides around, there's no way it's gonna come unplugged. And we haven't had any issues with it coming unplugged this year like we have in past years. Okay, so moving on from the drive to kind of an aspect of the drive, but the sleds. So we've been running Lexan sleds doubled up with a curve, and you can see all the nylon screws in there just to keep weight down. We had to put some steel ones in there to keep it from breaking. And so basically these just allow us to ride up on the barrier. It goes over. We do have to be going at a pretty good speed to get over generally because our robot's really balanced, but we didn't really have any issues with crossing the barrier at our competitions. And you'll see this wedge back here. It's just there so we can push the eyeballs over with the back there and also push them into the goal more easily. Start. Okay, so moving on from the sleds to our wings. So our wings, I'm gonna unfold them. So you can see that they're high strength axles with holes drilled in them for zip ties and mountings. And you can also see that our wing here it's at an angle to help push over the tri-balls, and it's attached by zip ties. So one interesting thing about our wings is, although they're rigid when they're going pushed forward, so you can see that I have no issue pushing over that tri-ball. So they're rigid when going forward, but they can flex up the other way. So that just allowed us to be able to de-score from the match load zones, that one tri-ball, by just spinning reverse with the one wing open, and that worked really well. It actually basically shot the tri-ball out of the zone and across the field. So we were pretty happy with that. You'll see that this wing has a section missing from the profile just because we were using this to touch the match loads bars, and we didn't want it to come out of contact with those, so that was just a little overhang. And it also helped de-score from the match load zones. I think we only used the left wing to really de-score. In the future, we're probably gonna change to locking wings. These just didn't work great for skills, but they did have enough force that they couldn't really be back driven super easily for pushing in like 6. So we had no issues with them in rounds for pushing stuff in. Okay, so one last thing about the wings. We could also use them as our secondary hang over the barrier A tier. So basically we would just line up with the barrier, open the wings, and then be able to drive over, and it would just balance right over the barrier. You can see we got a pretty good clearance, and then if we ever wanted to get off, it's a clean clearance to go off. We didn't really have to use it as much because not a lot of people had the B tier hang that we had. But we were able to use it at some competitions. Okay, so moving on from the wings to the intake. So you can see we're running a 2-bar intake, 600 RPM motor, 11 watt. There's not really a lot special about it. So basically we could intake, let me turn on the program. So we could intake forwards, outtake. We have the non-slip because some of our bands were getting caught in other robots, and this kind of just was a preventative measure from that happening. So you can see that we can intake. The kata is at like halfway down just to keep the ball from going up. And we did have intake to kata enabled. We never really used it though, so we probably won't do intake to kata again. But you can see that we can go to the goal, outside work at the same time. So that worked really well. Okay, so moving on to the kata. So as I just said, it was at halfway for intake just to block the tri-ball from going up. You can see that it can't get through there, and then we can just outtake the tri-balls into the goal. So this is what it normally sat at during a match, but we could also set it all the way down for intake to kata, and then we can fire it. And we had on our controller, we had just pushing this button for single fire, and then an automatic retract using a PID loop. And then we had a shift key button and press this again for match loading. And so that was our rapid fire. And that worked really well for skills and for matches. We were able to get about 100, this is about 100 shots per minute. It's a 25 RPM kata. And assuming the bands it's not fighting against too much band power, we were able to get a pretty consistent, we were able to get all 44 off in skills in like basically 30 seconds. So on our kata, we have two types of match loading. So the first type is during rounds, we would load into the kata. So we have this latex tubing to keep the tri-ball from sitting down into the kata, just to give it a higher arc. And it was pretty much just set it in the kata and go. And usually the arc was higher than that. During rounds, we have a different orientation we set it in. So it was generally above these hang poles. And then our second type of match loading is the slapper, which are these two rubber feet on these standoffs, and then our platform. So pretty much the tri-ball just went in at the ideal angle, and then we would shoot that across. And that worked really well for skills. We were able to get the cluster almost like all the tri-balls in front of the goal. We were able to shoot off all 44 in about 30 seconds. And it's not really too difficult to match load either. So I'll show you that again. So that worked really well. We were really happy with this. And then you may have seen in the past, we had a solo Aton wind point. We were not running it at Speedway, but basically we had 22 Aton bands that went to the kata and hooked to these band releases. And the way these band releases worked is you'll see this screw right here on the kata. So this screw was down, and this was before the kata was engaged. And then this would sit right on that screw, and that would hold everything. And of course the kata is disengaged and just held down by our intake. So we would release the kata when the intake released, and it would shoot with the power of the 22 bands on it. And then when we started spinning the kata, the screw would spin and come out of contact with this, and this would be able to pivot up, and then that released all of the bands. You'll notice we used steel inserts for this part that was in contact with the screw. We were using standoffs before, and the bands had enough power just to have the screw dig into the standoff because it was aluminum, and that caused the entire kata to jam. And we stopped running that because one, the slapper was not very good at transferring all that energy into the tri-ball. So we needed to have an absurd amount of power on the kata. And then two, it was really bad for the kata. We ended up snapping some L channel. Even the boxed L channel started snapping. So we just stopped running it for reasons that the robot just couldn't take that much power. So we weren't running it at Speedway, but everything else worked for the kata during rounds. Okay, so moving on to the last part of our robot, which is the shield and the end game. Oh yeah, so you'll notice that we have these zip ties all over the front of the robot. If you haven't guessed, that was to touch the elevation bars for wind point. Unfortunately, we were very close to getting the wind point in several rounds at Speedway, but it would always happen that one of these zip ties would be about a centimeter away from touching. So we just kept adding more and more and more, and so that's why we have all those on there. We did eventually figure it out, but that's why all those are there. So moving on to the shield. So we had it's about a 27-inch shield, and you can see that we have this overhang to prevent any shorter bots from match loading over the shield, and it worked in many of our rounds. We were able to block a lot of match loads. Unfortunately for the tall giraffe bots, it was just at the height of most of their platforms, so they were able to shoot over it, so we weren't able to really use it close up and had to back farther away. But it worked for every other bot except those. And then this also is off of our hang mech. So you'll see these two standoff hooks. So I should actually explain how this is powered. So this is powered using 4 pneumatic cylinders. So they are on separate solenoids. So you'll see that it's 2 cylinders up, and with all this rubber banding to help pull the robot up too. And then it's 2 cylinders down. But since they're on separate solenoids, we're able to have these just power it up and then release them to go down, so we're not wasting the air and having all the cylinders pulled down. So that's how we were saving air. And then when we're ready for in-game, it's basically drive over to the hang bar and then get over the hang bar, and then it pulls up with all of these, with these 4 cylinders. So during rounds, it just released the top 2 and pulled down with the bands. But when in game at the end, it pulled down with both the bands and the power of the cylinders. And we could actually get 4 hangs off with this. So that's opening and closing, and with the cylinders pulling down with the bands. So we were actually able to get 4 hangs off of this, which is a lot. It also helps having a 13-pound robot. But it is a B-tier hang. You can see it hangs down just a little bit, but that didn't cause any issues because it was well within. Okay guys, I think that is all we have for Sparky the robot. He's gonna see one more competition, so he's not quite done yet, but we are going to be rebuilding soon. So I hope this helps. If you have any questions, leave them in the comments and we'll get to them. Best of luck in the rest of your season.